Use the graph below to decide which of the following equations are true. So before I even look at these equations, let's think about what's going on here. So I have a line, and then we've defined all of these right triangles where the hypotenuse of the right triangles are the line. And you could view this right triangle, say this one in red, as really side C is our change in y, our vertical change as we go from this point to this point, and side D right over here is our horizontal change. Notice we go D to the right and then we go C up. If you're starting at this point and going to that point, side B is your horizontal change and side A is your vertical change. And the one thing we know about lines is if you construct these right triangles like this, your change in y over your change in x, the ratio between those two is always going to be constant. We call that ratio the slope. We also know that these are going to be similar triangles, that the ratio between corresponding sides is going to be the same. So these are obviously right triangles. These are horizontal lines, these are vertical lines, and all of these are similar triangles. And the ratio, and because they're all similar, the ratio between this vertical side and this base right over here is always going to be the same. So for example, we know that the ratio of A to B is going to be equal to the ratio of C to D, Now let's work through some of this other stuff right over here. So they say y plus 1 over x plus 2 is equal to the ratio of A to B. Let's see if that's right. So this is the point x comma y. So what's y plus 1? Well, y plus 1 is literally the same thing as the length c right over here. Notice this height, let me do this in a new color, this height right over here, this is y, but then if you add 1, you get all the way down here. So this right over here is y plus 1, and then this base right over here, once again, you see this is x plus 2. This length right over here, let me see if you can see it, this length right over here, that is x. You start at x equals 0, you go 2, or it looks like 2 to the right, but you go x to the right, and you get right over there. But if you want to get all the way over here, you have to add 2. So this right over here is x plus 2. And we know the ratio of this height to this base right over here is always going to be the same. So the ratio of y plus 1 to x plus 2 is going to be equal to the ratio of C to D, which is the same thing as the ratio as A to B, Now, that's what they're saying right over here. Y plus 1 over x plus 2 needs to be equal to A over B. Y plus 1 over x plus 2 needs to be equal to A over B. So that one's right. Here they've swapped them. They've swapped the two, and then now they're mixing A and D together. Now this is kind of a strange thing that they're doing, looking at the ratio of A to D. You could swap these two. And say, well, what's the ratio of x plus 2 to y plus 1 going to be? If this ratio is always constant, then the inverse ratio, or I should say the reciprocal ratio, is always going to be constant as well. We could call that 1 over the slope. So x plus 2 over y plus 1 would need to be equal to the reciprocal of this, which would be d over c, which would be the reciprocal of this, or b over a. Do we see that here? No, they've mixed it all up. They've mixed the a and the d together. X plus 2 over y plus 1 is not the same thing as a over d. We're not even using corresponding sides. We're mixing up triangles, so this is not the case. Now they say y over x, the ratio of y over x needs to be the same as the ratio of c over d. So what's y over x? So y is this length right over here. That, what I did in black, that is y. I don't want to cover anything else. And what is x? X is this length right over here. So that you could construct a right triangle that looks something like this. But notice, this is x right over here. Its hypotenuse does not. It's not its hypotenuse is not the line. The x is not going from. It's not essentially our change in x between some starting point and some ending point. We're starting at the origin and we're getting to xy. It has a different hypotenuse than the actual line. So this triangle is not similar to all of these other triangles. So the ratio of y over x is not going to be the same as the ratio as c over d. So this is not going to be the case. If this line went through the origin, then maybe we could talk a little further about that, but this is definitely not going to be the case. Now let's look at this. C over D, the ratio of this entire height, and I know I'm using too many colors right here, it's hard to see. So C is this entire length. The ratio of C to D, so this is our slope, the ratio of our rise over our run, the ratio of our change in y over our change in x. So the ratio of C to D is equal to A over B. Well, that's the definition of our slope. This ratio is constant when we're dealing with the line. So this is definitely true. Now let's actually input it into the exercise and make sure that we got it. So we have, actually that's not the exercise there. We have that one, and we have that one, and we can check our answer, and we got it right.